Good morning to all. This is Anvesh, and this is Anvesh from AAA branch. And today, the topic is about the conversion of a spherical coordinates to the cylindrical coordinates. So let's start this. And first of all, the Cartesian coordinate system provides a straightforward way to describe the location of points in space. Some surfaces, however, can be difficult to model with equations based on the Cartesian system. This is familiar problem. Recall that in two dimensions, polar coordinates often provide a useful alternative system for describing this location of a point in the plane. Particularly in the case involving circles, the session will look at the two different ways of describing the location of point in space, both of them based on the polar coordinates. As the name suggests, as the name suggests, the cylindrical coordinates as the name suggests, the cylindrical coordinates are useful for the dealing with the problem involving the cylinder, such as the calculating volume of the round water tank, of the amount of oil flowing through a pipe. Similarly, spherical coordinates are useful for dealing with the problems involving spheres, such as finding the volume of domed structures. Now the spherical coordinates. So now in the Cartesian coordinate system, the location of point in space is described using of an order triple in which each coordinate represents a distance in the cylindrical coordinate system. The location of a point in space described using the two distance and an angle measure. And the spherical coordinates, we again use the order triple to describe the location of a point in space. In the case, the triple describes one distance and two angles. Spherically coordinates make it simple to describe a sphere. Just a cylindrical coordinates make it easy to describe a cylinder. The grid lines for spherical coordinates are based on the angles measured like those for poles coordinates. Uh, we again use to order the triple to describe the location of a point in space. In this case, the triple describes the one distance at two angles. The spherical coordinates make it simple to describe a sphere. Just a cylinder coordinates make it easy to describe a cylinder. Grid lines for the spherical coordinates are based on the angles measured like those for polar coordinates. And the definition in spherical coordinate system. In the spherical coordinate system, a point P in the space is represented by the order triple uh, rho theta phi, where rho is the distance between P and the origin, where rho is not equal to 0, and the theta is the same angle used to describe the location of the cylinder in the coordinates. The phi is the angle formed by the positive z-axis and line. Again and again, again the spherical coordinate system, a point P in space is represented by the order triple rho theta and phi, where rho is the distance between the P and on the origin, where rho is not equal to 0. Theta is the same angle used to describe the location in the cylinder coordinates, and phi is the angle between formed by the positive z-axis and the line. The theta is the same angle between used to describe the location of the cylinder coordinates, and phi is the angle formed by the positive z-axis and the line. And now this is where the spherical coordinate system is to be drawn, and if you know, it is a x-axis and it is a y-axis and it is x-axis, where theta is the angle between the y and the z-axis, and where phi is the angle between the theta away the angle between the z and rho axis, and where rho is the angle between there is a line between the y and z axis from origin, where rho is x comma y comma z the Cartesian coordinates, and p rho comma theta comma phi and the spherical coordinates. Now to convert the spherical coordinates to the rectangular coordinates. So these are the equations are used to convert from spherical coordinates to rectangular coordinates, where x equal to rho sine phi and cos theta, and y equal to rho sine phi and sine theta, and z equal to rho cos phi, So these are the conversions that are from spherical coordinates to the rectangular coordinates. So like this we have to do to convert the spherical coordinates to the rectangular coordinates. So this is the one. So again, these equations are used to convert from spherical coordinates to the rectangular coordinates, and where x equal to rho sine phi and cos theta, where y equal to rho sine phi and sine theta, where z equal to rho cos phi. So these are the things, so these are the three formulas that to convert the spherical coordinates to the rectangular coordinates. So these are the things we have to do. And now the conversion from the rectangular coordinates to the spherical coordinates. So these are the equations are used to convert from rectangular coordinate to the spherical coordinate, where rho square equal to the x square plus y square plus z square. The tan theta is equals to y by x. The phi equal to cos inverse of z by x square plus root over x square plus y square plus z square. So these are the three formulas which are convert from rectangular coordinates to the spherical coordinates. So these are the formulas where we have to so from these three formulas we can convert the rectangular coordinates to the spherical coordinates. So thank you for giving this opportunity.